Okay, Assalamualaikum. So today we will enter a new chapter, chapter 6, applications of hydrology. For this introduction hydrological budget, you have learned this hydrological budget before. And today we will learn about rational method. Okay. So this is hydrological cycle that you will learn previously. Okay, for the catchment and water budget, so each mountain we will divide into two to get the catchment area, right? Also called as drainage basin, drainage area, or stream watershed or river basin. So this one you have to know that changes of storage is equal to inflow minus outflow. This equation you have to remember. Right, so this example you have to know how to do it, and we enter to simple rational method. So this rational method is used for flood estimation. Alright, so this is a simple method. By using a formula or IDF curve, you can know what is the flood estimation. So for flood estimation, we only estimate the peak surface runoff. So this one, peak surface runoff rate. Alright. So given length of storm sewer, storm water inlet, okay. So there is a variety of design. So maybe you have to design length of storm, design a storm water inlet, or design water detention pond. So it is suitable for small urban watershed. So for rational method, you have to calculate what is peak runoff or QP. So this is the formula. You have to remember this one. So K is conversion factor. So I don't want you to use this K factor, but you have to know how to convert I and A. So I is rainfall intensity, A is area, drainage area. So C given runoff coefficient given in the equations. So by using this K, A should be in kilometer squared, I should be in millimeter per hour. So that's why I don't want you to memorize using this 0.278. So you have to know how to convert I into meter, A to meter squared. So QP use a meter cube per second. Okay. So this simple rational method is best for area less than 100 acre or less than 1 kilometer squared. So you have to calculate the area is less or 1 kilometer squared or greater than 1 kilometer squared. So if greater than 1 kilometer squared, so you have to use a modified rational method. So we will go through this modified rational method later. So 100 acre is alright. So but sometimes use up to 2 miles squared. Right. So this one. So the peak runoff Q is peak surface runoff. Peak surface runoff rate. So this Q, small q. So it's actually QP is equal to Q. Okay, QP is equal to Q. So CFS is cubic feet per second. So feet cube per second. Right. So this I in inch per hour. Okay. That's why we use this K value, conversion unit, conversion factor 0.278, and then you will get meter cube per second. But I don't want you to use 0.278 because you have to memorize this one in inch per hour, and then this one in CFS, right? So unit for peak runoff rate is actually this one lah, right? So it actually is acre inch per hour. So if you convert into metric unit, so you get meter cube per second is actually okay for peak runoff rate. All right. So runoff coefficient actually depends on vegetation cover. Okay, types of vegetation cover, either it's pavement or have a grass. Alright, so if the rainfall become runoff, C is equal to 1. So this one is C, runoff coefficient. So you see here that playground is 0.2 to 0.35. Okay, different types of land use, different C. And if you given a different types of C, so you have to find out what is the overall C for that catchment area. So if you want to find the overall C, so you have to find out a total CA divided by total area. So rainfall intensity actually depends on storms recovery interval. Okay, so we can record the rainfall and average for numbers of years, sometimes 2 years, 5 years or 100 years. So this time span is identical storms is called recurrence interval or return periods of the storm. So to determine the rainfall intensity is actually we can use IDF curve, in intensity, duration, frequency curve. Right, so this IDF curve will be given. So different area, or for example Gombak or Putrajaya or Seremban, so it will have a different IDF curve. Okay, so this IDF curve will be used this TC, times of concentration. Okay, so times concentration is actually maximum time to travel of fluid falling the land surface. For example, or this one given okay, or time inlet. All right, okay, time concentration, so maximum time to travel. All right, so you have to remember it. So TC actually you can get from this formula. TC is equal to T naught plus TD. T naught is actually time only over land. D is drain. Okay, T drain plus T over land. So it's time concentration. So this rational methods is normally used for small catchment, only small catchment up to 1.5 km square. Okay, if greater than 1.5, we use modified rational method. So example 6.1. Right? So during 8 hours, times is 8 hours, a total of 100 ml, this one is I, okay, sorry, this one is P, rainfall was recorded area of 40 hectare. Determine the rainfall intensity. So question need you to find I, what is I of the storm, and total volume of rain that fall into the ground. So I here is, okay, so this one okay, I is unit the mm per hour, so 100 mm divided by 8 hours, you get 12.5 millimeter per hour. So you get the volume unit is meter cube, so you have to find out that times times dengan area. So given depth here, okay, 0.1 meter times dengan area given 40. So this one depth lah. Okay, 100 mm ni is depth of rainfall tu. So convert into meter, 0.1 meter. So you get the volume. Alright, so example 6.2. Okay, estimate the peak flow resulting from a storm. Okay, given I 75 mm per hour and catchment area A 5 hectare. So assume runoff, so only C. So you have C, I and A. So I don't want you to remember this one, 0.278, but you have to know how to convert from millimeter per hour to meter, hectare to meter square. So C times I times A. So this one C, my C. Okay, 75 meter per hour. So convert into meter per hour, meter per second. This one 5 times power of 4 meter square area. So you will get, calculate here, okay, you can calculate this one and then you will get this value, 0.52 meter cube per second. Okay, example 6.3. Okay, given for a catchment area, so ada different C, so you have to area every each this one. So you calculate total C times A divided by total area, and then you get C value. So C value for this question is 0.286. Right. Example 6.4. Okay, given time 5 years peak flow at a stormwater inlet and area 30 times power of 4 meter square. Okay, time inlet is 20 minutes. This one they have a different land use, housing, commercial park. Okay, so we get the C from this question. Total C times A divided by total area, so 0.36. Okay, to determine QP, so I have here. Okay, C given 0.36. So to get QP, you have to use IDF curve. So assume that the area in Subang, so that we can use IDF curve Subang to get I, and inlet, this one TC. Inlet time is TC. TC is 20 minutes and 5 years return period. So this one meaning that this one 1 in 5 years. So one time occurred in 5 years. It means 1 in 5 means one time occurred in 5 years. So we use the IDF curve to get I value. So this IDF curve is actually intensity in inch per hour versus duration in minutes. So you have TC in 20 minutes, right? So 1 in 5 years. So we use 1 in 5 years. 1 in 5 years, bulat dia square. So TC 20 minutes, and then you from this graph you will get this I is equal to 6.4 inch per hour. So then you have to memorize 1 inch is equal to 25.44 millimeter. So from this graph, when we convert into millimeter, then you get I is equal to 162.5 millimeter per hour. So I don't want you to remember this one 0.278, but I will use the normal conversion. Okay, you get C 0.36, I 6.4 inch. So convert inch into meter per second, and then area A is 30 power of 4 meter squared, and then you calculate by using calculator, you get 4.88 meter cube per second. So you don't need to remember this 0.278. Okay, this one for example 6.4. Okay, you get the peak rate runoff, and then we learn about modify rational method. So refer to the statement before. 1.5 or less than 50 kilometers squared, you have to use modify rational method. So if for larger catchment area greater than 1 kilometer to up to 50 kilometers squared, this simple rational method not applicable. So you have to use a modify. So convert 50. Okay. So usually question give you in hectare. So if you convert, you have to convert it into 1 kilometer squared or 50 kilometers squared to determine either you have to use simple or modified rational method. Alright, so this one rational method. Okay, and then if you modify, you have CS. CS is storage coefficient. Alright, so CS, to determine for a larger catchment, CS is actually 0.67. Okay, or you can calculate by using this formula. You have to remember this formula. CS is equal to 2 TC time concentration divided by 2 TC plus TD. TD is drainage time. So for catchment area is actually CS is 1.0. So that's why for this one for smaller, this one is larger catchment area. So smaller is CS is equal to 1. So that's why we get 0.278 CIA only. So this CS is actually you can find out from MASMA. Okay, this one I download it from Google. You can get a MASMA second edition, page 76. You can see that this is the method how to calculate. Okay, so it's actually okay, TC is actually is equal to T0 plus TD. Alright, so this is the method. Right. So exercise number 1, you have to find out the runoff coefficient for the total catchment area. So actually, okay, this question is not, cannot do on this equation. Okay, so exercise number 2. Okay, area 50 hectare, catchment. Okay, this one this area, this one this area, area. Okay, runoff coefficient, this one area, this one C. The overland flow distance to the beginning of stream that drains the catchment is 210 meter, right? The ground slope, this one slope 5%, and the stream is 900 meter long with an average. In stream, so you have stream, so this stream is 900 meter long, and the velocity is 0.35 meter per second. So estimate QP for 50 years peak discharge using IDF curve for submarine. Right, this one is exercise number 2. Right, so first what you should do is find the T naught. Okay, alright, so given in feet. So this one lander they've given, okay, stream that drain the catchment area is 210 meter. Okay, we use this overland punya overland travel distance and overland time of travel curve. So you have a catchment area 210 meter, convert into feet because this one in feet, so I get 690 feet, and then my slope is 5%, so this one 5% slope. Alright, and then I expand from 690 feet to slope 5%, and then extend to the runoff coefficient given is 0.35. Okay, so 0.35 at the center of 0.3 and 0.4, and then expand until you get the time naught. So time naught is 25 minutes. Okay, so time naught is 25 minutes, and then we have to find TC to use IDF curve. IDF curve, you have to use TC, not T naught or TD. So TD, okay, given in the question, so length of stream is 900 meters and the velocity is 0.35. So convert, okay, and then you get the time. This time is time to drain lah. TD, so you get in second and then convert into minute. So TD I get 43 minutes. So TC, T naught is 25, TD is 43. So you get 68 minutes. Right? Okay, so from this 68 minute TC, then you can use IDF curve. So IDF curve here, IDF curve Subang. So given in the question is 50 years peak discharge. So I use 1 in 5, 1 in 50. 1 in 50, so this one TC. TC 68, and then 1 in 5, 1 in 50, and then I get my intensity, rainfall intensity is 4.3 inch per hour. And then using this equation CIA, so C 0.35, I 4.3 inch per hour, convert into meter per second, and area given in the question is 50 hectare, so convert into meter square, and then I get 5.31 meter cube per second. Okay, I repeat the step. So first you have to find out T naught, and then find out TD, and then using TC is equal to T naught plus TD, and use IDF curve to find I, and using the equation QP is equal to CIA. If A is greater than 1 kilometer squared, you use a modified CS. So your question will be QP is equal to CS CIA. Right? And then exercise 3. Okay, this one is exercise 3. Okay, given an ideal land in Subang having an area 150 hectare. Okay, so if given area 150 hectare, so I have to confirm either I will use modified rational method or simple rational method. So if I convert is greater than 1.5 is greater than 1 kilometer squared, so I use modified rational method. Okay. So I have to find out CS. So given in the equation, runoff coefficient 0.9, flow of velocity 0.5 meter, and the stream is 1 kilometer. Okay, V is velocity is 0.5 meter per second. The ground slope is 3%. It means 100 years peak discharge. So we have to find out T naught first. So T naught, okay, so I have convert this one. Okay, L naught the 170 meter, this one. Okay, L naught. So convert into feet. So I get 558 feet, and then slope 3%, even in the equation. And then C is 0.95, and then expand, I get T naught 8 minute. So you have to find out TC. TC is equal to T naught plus TD. So 8 minutes. So TD comes from this stream, 1 kilometer divided by 0.5 meter per second. I get TD is 33 minutes. So 33 minutes. So I get 41 minutes. Then I will use IDF curve. TC 41 minutes. And then given in the equation 100 years peak discharge. And then TC is 41 minutes, 1 in 100 peak discharge. So I expand, and then I get I is 6.5 inch per hour, the rainfall intensity. So previously we have to use modified rational method. So we use this equation, CS 2TC divided by 2TC plus TD. So TC 41 minutes and TD 33 minutes. I get CS 0.71. So this formula QP is equal to CS CIA, and then put into the equation, and then I get my QP for example 3 is 43.96 meter cube per second. So that's it for today, rational method, exercise 3. So we will see you in the next class. Thank you very much.